Hello, Ms. Toshner. This is Adam Shamoon, and today I'm going to be doing problem number 20 from the chapter 3, week 2 videos. So just to get started off the bat, I noticed a couple things about this function is that the leading coefficient has the leading term has a very high exponent. And so usually we deal with x squared as our highest exponent in a given function. And so what I'm going to do to get that to get that down to an x squared is use a method called factoring. So what we can do here is we can factor out an x cubed because all of these terms have an x cubed in them. So if we remember from Algebra 1 material, the rule for subtracting exponents or for factoring out exponents. So when you factoring is like dividing. So when you divide one exponent by another, it's essentially like subtract, or when you divide two numbers that have an exponent, it's like subtracting the exponent. Okay, so with that in mind, we know that we can take out an x cubed because that's the lowest term here, and it can also fit into all the rest of these. So we're going to go f of x equals x cubed, and so we can use the same rule here, x to the fifth, so the one that I was talking about earlier, x to the fifth over x squared, or x cubed because that's what we're factoring out, is x to the 5 minus 3, which is x squared. Next, we have 4x to the fourth divided by x cubed. And that's going to be 4x to the fourth minus 3, which is just 4x to the 1, or just 4x. And then next, we're going to have plus 4x. Next, we're going to have 4x cubed divided by x cubed. And we know these can cancel, but I'm just going to write it out anyways. 4 to the x, 3 minus 3, 4x to the 0. And remember that x to the 0 always equals 1, any number, so it'd just be 4. So with that in mind, we can simplify this equation even more. So this polynomial right here is factorable. So that's what I'm going to do right here. So remember that for a polynomial, to factor it out, the two factors have to add up to the c term, to the b term. They need to add up to the b term, which is 4, and they need to multiply to the c term, which is also 4. And so using basic math, we can just figure out that that's 2. So next, we can simplify this to x cubed times x plus 2. So this is just going to factor out into x plus 2 times x plus 2. So I'm just going to make that x plus 2 squared because anything times itself is that number squared. And so now we need to find the zeros of our function. So in order to find the zeros of our function, we're going to set f of x equal to 0 and then set our two terms equal to 0. So f of x equals 0. So 0 equals x cubed times x plus 2 squared. And then we're going to make x cubed equals 0 and x plus 2 squared equals 0. And next, we're going to simplify. So I'm going to cube both sides. So 0 cubed is always just going to be 0. And then we're going to take the square root of 0, which is just 0. So x plus 2 equals 0. Subtract 2 from both sides to simplify it more further. And we're going to get our two zeros, which are x equals negative 2 and x equals 0. And so now to graph a function like this, we'll have to take into the account the multiplicities of each of the zeros. So if we recall from what we learned in Algebra 2, we know that each, depending on the multiplicity of a zero, it'll cross its x-intercept in a different pattern. So there are 3 patterns that we learned that it can pass through. So if you just give me a moment while I finish writing these out. So the first is linear. So linear happens when there's a multiplicity of 1. So let's just assume that for all these examples, the x is 0, so that's just going to be 0, comma 0 for our x-intercept, just to make this a little bit easier to explain. So if our multiplicity is 1, we'll pass through our x-intercept in a linear shape. So that means if you zoom infinitesimally smaller than this, you'll always see that straight line linear shape going through. And next is our quadratic shape. And this is when we have a multiplicity of 2. So it'll take the shape like this. It'll always bounce. It looks like it kind of bounces off the x-axis here. So if you zoom in, it's always going to have that shape where it goes down, and as it hits the x-intercept, it goes up. So this is always going to be the shape of something that has a multiplicity of a 0 that has a multiplicity of 2. And so now for our multiplicity of 3, our cubic shape, 3, it's going to look like this. And that makes sense just because, I mean, if you look at basic rules of end behavior, that's how an odd degree with an even function is going to look. And same with this one. If you look at end behavior, it because a quadratic will and a multiplicity of 2 will have an x squared in it somewhere, then it makes sense that because it's an even degree and it has a positive leading coefficient, that it'll take the end behavior as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches infinity. And same for this one. This is x to the 1, and because it has a multiplicity of 1, and so it'll take the same end behavior as the third, the cubic one, because it has a positive leading coefficient and an odd degree. So as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x will approach negative infinity. Okay, and so that's just going to be the same one here. X approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. And you can see that here if you just look at the graph simply. Okay, so now we're going to actually graph our function. So let's just take our zeros. So I'm just going to draw a graph over here. Okay, so now we're going to draw our zeros here. So let's just take note of the multiplicities that we have at our zeros. So x cubed has a multiplicity of 3. So we can just write it like this. It's the same thing times x plus 2 squared. So the 0 for this is just 0, and the 0 at this like this factored number is just going to be negative 2. And this one has a multiplicity of 2, and this one will have a multiplicity of 3, as shown by their exponents. So we're going to draw our x-intercept. We're going to have one at 0, one x-intercept at 0, and we're going to have one x-intercept at negative 2. So let's take note of the end behavior that we see in the beginning of this problem. So it has an odd degree and a positive leading coefficient. So that's just going to be the same end behavior that we saw here. So as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x will also approach negative infinity. So that means that we're going to start here and we're going to end up here. Okay, so I'm just going to continue drawing this line. So we're going to keep drawing until we arrive at our first zero. And here's our first zero. So this is -2. It has a multiplicity of 2. So that means we're going to bounce off at a quadratic shape like I drew here. Okay, and so we're now arriving close to our next zero, which is 0. And so if we notice here, our multiplicity is 3. So we're going to have to approach it with a cubic shape. So if we go like this, if you zoom in, you'll see how it has a cubic shape. And it's just going to continue up here in no particular specific way, just until it reaches the end over here where it has the shape of the end behavior. So just to summarize a little bit, here are two zeros at -2, comma 0 and 0, comma 0. So I determined this graph by looking at the x-intercepts of each of the factored form of this function. So the two zeros were -2 and 0. So what I did is I looked at the multiplicity of each of the zeros for x for 0 for the 0 0, the multiplicity was 3, and for the 0 -2, the multiplicity was 2. And I graphed those x-intercepts out and used the multiplicities to find the shape that the graph will make around every x-intercept. And then I also used the end behavior of the function by looking at the leading term's coefficient and also the leading term's uh, degree. And I'd use those to determine this function, which is the final answer. And yeah, this is all these are the graphical features right here. We have the end behaviors, we have all the x-intercepts, we have the end behavior, multiplicities here, all the zeros. We had the zeros right here, and that's it. Thank you for watching my video. Here's my final answer. Here are my final answers right over here, and thank you for watching.